Yo, yo, yo! Welcome. I found an interesting question on one of the textbook new Qmath 12B chapter 4 chapter review question 22, and I thought interesting modeling problem solving question, and it's a bit of tricky as well. So decided to make videos about it. All right. So here, the question 22 is the cross section of a riverbed is shown at right. All right, so that's a little picture of the river. The deepest part of the river is toward one side at C, 6 meters from bank B and 12 meters from bank A. Okay, and the water level is the line AB. Yep. If the origin of a coordinate system is placed at A, then the curve from A to C can be written as y equal to x squared over 24 minus x. And the curve from C to B can be written as y equal to x squared over 6 minus 4x plus 18, where both x and y are in meters. Alright, big question. But we got a diagram, that's good. Okay, alright, let's focus. Focus and let's begin to solve the question. And when you focus, what do you need? You need BGM. Okay, here we go. Alright, so we know the cross section of a riverbed is shown on the right. The deepest part of the river is toward one side at C. Alright, so this is the deepest part. Okay, 6 meters from bank B. So from here to bank B is 6 meters. And 12 meters from bank A. So from C to bank A is 12. Right? And the water level is the line AB. Okay, so this is AB. From here to here, water level. Okay, and if the origin of a coordinate system is placed at A. Now, what does that mean? That means if we draw the Cartesian plane origin here. Right? Like that. Then the curve from A to C can be written as this. So the curve from A, so let me rub out a little bit here. From A to C, so this line can be represented as a function of this y equal to x squared over 12 over 24 minus x. All right, and the curve from C to B, like the curve from C to B, it still starts at A. All right, so because it says the coordinate system is placed at A, so that means I will use a different color. That means from A through to C, then to B. Right, this function is given by this particular equation. Okay. Yep. So we're both x and y are in meters. So good. So we know our units. They're in meters. Very important to know your units. Alright, find the maximum depth of the river. Well, first, we need some graph. Alright, we need to graph these two functions. Alright, let me go to Desmos. So, here is the function. Alright, so the first function is our A to C function. So from A point is here, C point is here, and B point is here. Alright, so I put a limit on the domain on the AC function, A to C function, because we know that from the origin, which is 0, x equal to 0, to x equal to 12, that's where C is. And afterward, the bank is represented by the other function, which is the C to B function. Okay, so on the other function, also put a limit on the x domain. It's from 12 to 18. Now, why 18 is because we know this distance is 6, and we know at this particular coordinate here, it has an x coordinate of 12. At this point, right? So that's why since the bank B is 6 meters away from the point C, so 12 plus 6 is give you 18. So we know there's a x value of 18 here. And since this is where the water level, so these two lines between A and B is the water level. So this must be 18, 0. So the coordinate 18, 0 there. Right, 18, 0 there. And this coordinate will be 0, 0. Alright, so that's our curve. Alright, so it says find the maximum depth of water. Find the maximum depth of the river. So the river is somewhere. Oh, so the deepest point is C, right? We know the deepest point is at C. So for the first function, y equal to x squared over 24 minus x, all we need to do is sub in x equal to 12. So we can get the y values, right? Oh, so minus 24, sorry. And then minus 12. Okay. And then y equal to 144 over 24 minus 12. Y is equal to, alright, let me calculate that. 144 divided by 24 give us 6. 6 minus 12 is negative 6. Which makes sense. So this one looks like it's a negative 6 value anyway. So we've got a negative 6. We've got 12 and negative 6 here. Alright? Alright, just in case, we should do that. We should confirm the point with the C to B function, which is the red function as well. The red color function. Alright, let me do that. So same thing, we're going to sub in 12 into the x. So y equal to x squared over 6 minus 4x plus 18. Alright, sub x equal to 12 in there. Because y is equal to 12 squared over 6 minus 4 times 12 plus 18. So y squared is equal to 12 squared divided by 6. That gives us 24. Minus 48, right? 4 times 12 is 48. Plus 18. So that is the same as 24 minus 30. Which give you negative 6. Right? So both tell us the y coordinate at x equal to 12 is equal to negative 6. So finally we can answer the question. Oh, remember, meter, your unit, very important. Alright, so we can answer the question. Therefore, the deepest part of the river is 6 meter, deep. Alright, that's good. That's question 1 done. Okay. Okay, B, find the cross-section area of the river. Okay. Now, since we've got 2 particular functions, alright, you can't do just one definite integration to find out the whole area. So we wanted this area. Alright, all this area. But you can't do it at one go because you've got 2 functions there. So we have to break it in parts. We have to break it into 2 parts, 2 sections. Alright. Don't try to do it at one go because it wouldn't work. You couldn't find a function that models it like that. Well, I suppose you could, but yeah, I will try to break it down into to reduce confusion. So let's just say at here, at the 12th mark here, things break out. So we got the blue section, which is the A to C function area with the x-axis, and the red and the C to B area with the x-axis. Alright, so we've got 2 sections. Alright, let's go. So integrating the A to C curve section is from 0 to 12, right? All the way top minus bottom. Integrate respective to x. Alright. So which is the top function? Now we know the bottom function is our A to AC function, the curve. the top function is this one. This one is just y equal to 0, which is the x-axis, yeah? But it's always top minus bottom. So it's 0 minus, that function is x squared over 24 minus x. X squared over 24 minus x. Integrate with respect to x. Alright, so that is the same as break the brackets, expand the brackets, plus x. Yeah, you see how important it is to do top minus bottom, because if not, you get the wrong answer, or you get negative answers, which doesn't make sense in terms of area. Okay, so let's integrate. So that's just negative 1 over 24 multiplied by the integral of x squared is x cubed over 3 plus x squared over 2 from 0 to 12. Alright, so that gives us negative x cubed over 72 plus x squared over 2. 12. Sorry, not 6. 0. How? Why would I put 6 there? Alright, let's sub the numbers in. So it's negative 12 square cube over 72 plus 12 square over 2. Minus, now the 0 bit, when we sub in the 0 into the x, you get 0. So I wouldn't bother writing it out. Alright, by now you guys should know that there's nothing, the 0 wouldn't give you anything. Okay, so it's 12 cube. Give us 1728 divided by 72. Give us 24. And there's negative in the front, negative 24. Plus 12 squared divided by 2. 72. Which give us 48 meter square of area. The unit is meter. So that is the section 1. Alright. So we can go back to the top. So this is section 1. Alright, let's do the section 2 now. So section 2 is the same thing, we integrate. From where to where? It's from 12, right? From 12 to 18. Top minus bottom. Integrate with respect to x. The top function is just like before, is the y equal to 0 function, which is the x-axis. So 0 minus. Let's see what is the y c to b curve function is x squared divided by 6 minus 4x plus 18. So it's x squared divided by 6 minus 4x plus 18. Integrate with respect to x. Alright. And let's expand the brackets. So it's negative x squared over 6 plus 4x minus 18. Integrate with respect to x. Alright, let's integrate. So it's negative 1 over 6. Take it out. And then the x squared integral is x cubed over 3 plus 4x squared over 2 minus 18x. Alright, from 12 to 18. Alright. Minus x cubed over 18 plus 2x squared minus 18x. Alright. Just writing it better, looking tidy things up. Alright, let's submit the numbers. Alright, it's equal to negative 18 cubed over 18 plus 2 times 18 squared minus 18 times 18. Right? It's something funny can happen here that later on. Alright, so minus negative 12 cubed over 18 plus 2 times 12 squared minus 18 times 12. Alright. Okay. Alright, let's go. So negative 18 cubed over 18 is just negative 18 square. Alright, let's keep it like that. Negative 18 square. Alright, plus 218 square. Alright, that's 218 square. And now this is negative 18 times 18, so that is negative 18 square again. Now, if you're good at algebra, if you pay attention, this is the same. They cancel out, right? So there's nothing in there anymore. 0 minus. All right, so 12 cubed divided by 18. It's 96. So negative 96 plus 12 squared times 2, 288, minus 12 times 12, 18 times 12, 216. Alright, let's solve what's inside the brackets. So negative 96 plus 288 minus 216 give you negative 24. And negative give you a positive value. So it's 24 meter square, and that is section 2 area. Right, so to find out the cross section, the total cross section area is just easy. So total area is equal to 48 plus 24 give you 72 meter square. Alright, so that is the answer. Okay, so let's answer the question now. So find the cross-sectional area of the river. Alright, let's answer it. Therefore, the cross-sectional area of water is 72 meters square. Yeah, perfect. Alright, let's keep going. Which is C. If the water flows at an average rate of 1.4 meter per second, how much water flow in 1 second? I love this question because it says how much water. Yeah. How much water means, look, how much water is, look, first is, we're not looking for area, we're looking for the water itself. Now, water itself in the 3D world is a three-dimensional, three-dimensional things. So what sort of unit does it have? So water should have a unit of liter, alright? And liter, as we all know, is also equal to meter cube. Okay? So we are given a meter per second here. Now what times meter per second give us meter cube per second? Alright? It must be meter square. Meter square times meter per second give us meter cube per second. Right? You can work it out. You can work it out just with the unit. If you're on top of things, if you know how much water means, okay, the volume of water. A volume unit is L, but water, especially for water, 1 liter of water is also equal to 1 meter cube of water. Yeah? So just like that, you can figure it out. So, how much water flow in 1 second is equal to the area of water, that is meter square, multiplied by the flow rate, which is meter per second. So this is meter cube per second, yeah? And that will give you that. So 72 times 1.2, was it? 1.4. 1.4. Give you 100.8 meter cube per second, or if you like, liter per second. Yeah? Good. So this is our question. This is our answer. So therefore, 100.8 meter cube per second of water is flowing through. It's flowing through each second. Oh well, since I said each second here, I don't need to put it's just 108 meters meter cube of water is flowing through each second. Good, perfect answer. All right, let's tackle the next one. A vertical levee banks 1.5 meter high are placed at A and B. During flood, the flow rate increases to 2.5 meter per second, and the water rises up the levees. All right. So what is a levee? Levee is just a little extra building. I would say a little extra building that's set up like that, which allow the river to contain more water, at emergency time. So this is 1.5 meter tall. Right, 1.5 meter tall. So we know that when it rains, okay, so the next question is, sorry, we should go number D first. Okay, find the amount of water that flows in a day. All right, so we know that 100.8 meter cube of water flows each second. So in a day, how much is that? So it's 108 times 60 seconds and 60 minutes and 24 hours. That will give you the how much water flow through a day. Sorry, we should have worked out question D first. That gives us 88,709,120 liter per day. Yeah? So, therefore, 8,709,120 liter of water is flowing through each day. Yeah? Okay. Then we go back to question E. Sorry about that, guys. Sorry, I overlooked the question. I mean, it's an easy one anyway. Still, don't do that in the exam. Please make sure you answer all the questions. Alright. Okay, so we already did that. So vertical levee banks, we already set that up. Okay, and then the flow rate increased to during a flood, the flow rate increases to 2.5 meter per second, and the water rises up to the levee. So we can assume these parts, right, it's all filled with water when it's during a flood, and the speed of it is increased to 2.5 meter per second. All right. So question E, finally, find the ratio of the flow of water in a flood to the average flow of water if the flood reaches the top of the levee bank. Alright, so we are assuming in the flood, the water has reaches the top of the levee banks. Is that how you pronounce it? Tell me if I'm wrong. Levee. Okay. Alright, so that means we just got an extra rectangle blocks areas of water. Right? This block is 1.5 meter high and how long? We know that. We know from C to B is 6 and C to A is 12. So 6 plus 12 is 18. So the whole thing is 18 meters long. So we've got an extra rectangle or block of water there. Right? Let's find out the area of that. Alright. So we go extra water hold by the bank, by the levee bank. extra area of water is equal to 1.5 times 18, right? It's 27 meters square. All right, so therefore the total area, area of water in a storm, in a flood. Oops. In the flood is 27 plus the one that we got before, which is 74, right? 72. Gives you 99 meter squared of water. And now we know that during the flood, the speed of the water increases to 2.5 meters per second. So we can find out the new volume of water that is going into the river. So 99 times 2.5 give you 247.5 meter cube of water per second, or liter per second. Yeah, so that's how much of water is flowing through the river per second when it's flooding. So let's go back to the question. It says find the ratio of the flow of water in a flood to the average flow of water. All right, so that we know the average flow of water is 108 meter per 100.8 meter cube per second, right? And now we know in the flood is 247.5 meter cube per second. So all we have to do is just divide the two together. 247.5 divided by 100.8 and give you approximately 2.455. Yep. So this is the ratio. So the ratio is, therefore, the ratio is 2.455. Oh, sorry, approximately, because we use the approximate sign, to 1. That's the answer. That is the answer. Right? Whew. That's nearly 30 minutes. Alright? Look, the reason I think this question is a tricky one is, first you have to understand, you have to be able to come up with the graph, or what we call it, the bank of the river with the two functions, setting limits on the x domain on each of the function to create the water bank first, right? And then the next bit is understanding the water flow in an average rate. So we're understanding the units between what you get with your answers. So to get how much water, the volume of water is flowing in 1 second, all you need to do is timing. You don't need to do is just find the area of, how much the area of the water occupies, times it by the speed of the water, just meter square times meter per second, give you meter cube per second, which is what we want. Yeah. And the last bit is just the levee bank. Alright, just set it up, understanding what that is, and then just set up another rectangle block of water area, and then add it to what you already got before, and then things very easy from then on. So those couple area I just mentioned is the thing that you have to be careful with, and other than that, it's quite a simple, easy question. But still, I think it's quite interesting and intriguing and tricky at the same time. Alright, 30 minutes now, okay? So that's it for today. Thank you for listening.